And you tell me where you want to start. Can you see that? Okay.
I already did some last night, 2 pages, and I knew how to do it.
Let's stick to the stuff that you're looking at and you're like, that you might get stuck on. Because if you already know something, there's no sense in us actually wasting the time on it.
So this is like further back, so I might not remember how to do it.
Okay. All right. Let me draw a set of parallel lines. Oh, well, I'm about to move that one. Let me try that again. So here are the lines. The lines go like. Okay. So what's it saying to us?
Line ES is parallel to line FT.
So I'm going to just do that.
Angle DGE equals 9x minus 17.
Can you identify where that angle is? Okay, so I'm just going to write that in there. So that's 9x minus 17. Okay?
And angle FHR equals 2x plus 10.
And this is 2x plus 10. Okay. Whenever you're dealing with parallel lines, either the lines or either the angles are equal to each other or they're supplementary. Do you know what the word supplementary means?
180.
They're 180. So this is how I do it. I'm going to do this in another color. So I'm going to put an X by all the angles that are equal to one another. And it's literally every other angle. So if I start at that angle, that one's 180. This one is the same. Okay? That one is 180. This one is the same. That one is 180. This one is the same. So if you go every other angle, did you see how I did that? You can determine whether they're supplementary or they're equal. All of the x's are equal. So if I look at this one and that one, are they equal or supplementary?
Supplementary.
They're supplementary. So what I'm going to do is I'm going to just add them all up and set it equal to 180. So this is 9x minus 17 plus 2x plus 10 is equal to 180. Oh, that's 187. I did my algebra wrong. And then that's 2. You get 26 points on it?
I had 17.
Okay. Oh, you were right. What's 9x plus 2x? I'm doing the math wrong. I'm subtracting. That's 11x, so that's right. Oh, then this means this is 18. 17, sorry. Let's go with 17. Okay, so what did it actually ask us for?
For angle, the measure of angle DGS,
So that's telling us what the x is.
So then we plug it into.
So we have to plug it in there. So you get 9 times 11 minus 17. So 99 minus 17 And that is 82. Better check my math because my math has been crazy this morning.
I don't know. I put 17 here because 17 is x, but...
Okay. That's where the... Oh, 17 is x. What am I doing today? Lord have mercy. Okay. So this is 9 times 17. Where did I get 11 from? I looked at that number. Minus 17 is equal to 17 times 8, 6. 146? Is that right?
I don't know if I did it right.
Okay. I don't know why my brain is not working this morning. Okay, so I'm going to take 17 times 9, and then I'm going to subtract 17 from that. 136. So that's my answer. Okay. You did the same one I got?
Mm-hmm.
Okay, so are 1 and 2 equal to one another, or are they 180 degrees?
180 degrees.
Mm-hmm. So what did they say angle 1 was equal to? And I'll draw it up again here.
8x minus 34.
So this is 8x minus 34. And what did they say that 2 was equal to?
2x plus 84.
2x plus 84?
Mm-hmm.
So we're going to do the same thing. 8x minus 34 plus 2x minus 84?
Plus.
Or plus 84 equals 180. So 10x plus 50 equals 180. And then, so x is equal to 13. Make sure I did my math right.
I can't think. I just woke up.
So did I. I don't blame you, man. Not at all. It gets the best of us.
13.
Yeah, 13. Now, did it ask us for the angle? Yes, it asked us for the angle. So we plug them both back up. So I'm going to do this one because the math is easier.
Wait, you could do either one.
Mm-hmm. So 2 times 13 is 26 plus 84, that's 110. So if this one is 110 and they're supplementary to one another, what would that one be? Because I don't want to stick the number back in if I don't have to. So this one is 110. If I add this one and that one, I get 180. So what do I do with 110 and 180 in order to find that angle? Subtract. So when you subtract them, what do you get?
70.
70, right. So that's both of them. Girl, there you go. Oh, you did the other one,
wait,
didn't you?
Both of them are the same?
Uh-uh.
Oh, wait, no, one's 110.
One's 110 and one is 70. So you could have taken 70 minus 180 and got 110. You just did the other one. Which I guess is good because we know our answer's right? Because we did the two separate ones. All right.
Well, I get how.
You get how to do those now? Okay, let's skip and do something else then.
might figure. I just don't remember.
This one down here?
Mhm.
Okay. It's
Well,
saying
this
that it's a
is-
parallelogram, right?
This is equal to that.
Mm-hmm.
So I just add them. There's no more y.
Okay, so you're gonna have to do that one last. So what do I know about that angle and that angle?
180.
Huh?
180.
180. So I'm gonna add those two together. So just so you have a picture. What do we have? 3x plus 6, and this one is 6x plus 3. And so we get 9x plus 9 is equal to 180. 171 is equal to 9x. And so this is equal to 19. That's right. And then, did they ask us for the angle? Or did
Just
they did x?
And then
Okay.
I don't know how to get y.
Well,
There's only one y. Do I subtract them?
How is this angle related to that
They're
angle?
equal.
They're equal. So if I stick in the 19, I can figure out what that angle is, right? So stick in the 19 to figure out what that angle is. So 6 times 19 plus 3. Plus 3. Okay, so I know that these two are equal. So what do I do with this number and that? This one's equal to 3
Add 'em.
Well, they're equal.
Oh, so you like do an equal
You
sign.
do an equal
and-
sign. So we do 3y is equal to 117. And then that goes in 3 times, and then that's 9. So that's, make sure that my math is right. 38. Maybe I was wrong.
I can do it again. 39. That's weird.
I thought it was 39 because it was 27, so. But. Yep.
I think I know how to do this one.
Okay.
Somewhat. So
Let me clear this. Okay, so that's our picture. Can you tell me the actual rule that we're going to use? So it said that 6x minus 38 is that one.
2x plus 10.
And this is 2x plus 10. And the outside one is?
5x plus 32.
The actual name for the rule is the external angle theorem. Do you know what the external angle theorem says?
I think I have to do the equal sign of
Equal sign and what exactly? Which one exactly?
this one and this one. No, this one.
It's actually these two. And I missed that completely. Let me go back. These two are equal to the one on the outside.
Oh.
Because if I take these three angles and add them up, I get 180. If I take this angle and that angle and add it up, I get 180. And that's why these two on the opposite side are equal to that one. So 2x plus 10 plus 6x minus 38 is equal to 5x plus 32. 8x minus 28 is equal to 5x plus 32. So 60 is equal to 3x. X is equal to 20. All right, let me check your math. Okay, so you have this one and this one, they go together and they give you what?
8x.
What about plus 10 and minus 38?
Negative 28.
If I move the negative 28 over there, how do I move it?
Oh, I added on accident. No, I did that right. Then I got...
Well, what's 28 plus 32?
Yeah, I added them wrong.
That's all right. I just made a mistake too. We all know what happens.
60.
Okay, so you got the same number I got. Good. Are they asking us for the angle? Or are they asking us for x? They're just asking us for x. The word question?
These two.
Of those two? Can you read it to me?
Line AC is an angle bisector of triangle ABD if angle BAD equals 102 and angle BAC equals 2x plus 1. Determine the value of x.
Okay. So let's draw the triangle first. And I'll label it. So this is A, this is C, this is D, and this one is B. Read the first part for me.
Line AC is an angle bisector of triangle ABD.
Okay, so what does that mean?
Like it separates them equal.
It means
I
that...
know it's from the angle to like the midpoint.
So that one and that one, those two are the same angle, right? What else did it say?
Angle BAD equals 102 degrees.
So BAD, the whole thing. So I'm going to make that mark in red so we can keep it straight. So that whole thing is equal to 102 degrees, right? Okay.
BAC is 2x plus 1.
Okay, so I'll put that in green. So this is 2x plus 1.
Determine the value of x.
Okay, what do I know about this angle and that angle then? If this is an angle bisector.
That's half of that.
That's half of that. So I can just take that number and divide it by 2, right? And then set them equal to one another. So what's 102 divided by 2?
51.
And now I'm just going to set them equal. Oh, you were right, it's 50. It's 25. Good.
And then this one's a perpendicular bisector.
Okay. So I am going to just get rid of some of this stuff. It's not going to let me. So let's just redraw it. Oops. That doesn't really look right, does it? I'm going to just freehand it. Oh well. If this is a perpendicular bisector, and I know it's not drawn all that great, but that means that this is perpendicular there, that's perpendicular there, and then these two pieces are equal to one another.
That's the midpoint, right?
Mm-hmm. That's the midpoint.
Do you want me to read that?
Just tell me where each one of the numbers goes.
X plus 2 goes in between BC.
BC is what?
X plus 2. 8x plus 2.
Okay. I was making sure I was reading that right. 8x plus 2 is that one.
And CD is 5x plus 17.
And what do I do with those two equations then?
You add them, equals 180.
Mm-hmm. What does these little markings right there mean? What do those two little markings mean?
They're parallel, congruent.
They're congruent. What's another way of saying congruent?
Equal.
Equal. So guess what I do with the two formulas?
Equal.
That's it. Did I do my math right? Oh. It's 17, right? Is that 17?
Yeah.
Is that? Just add a 1. Just add a 1 to the 5. There you go. Okay, so now what do I have to do with that number?
You plug it in.
You plug it in. I'm going to plug it into this one because the math is easier. So I have 8 times 5 plus 2. So if this is 42 and this is 42, then you add those together and what do you get?
84.
84. 84 is our answer.
We would do this one the same as we did the angle bisector, right?
No, you got to do that one slightly different. So let me draw it for you. Okay. What does the word altitude mean?
Like the height, but not
No. Altitude and height are the exact same thing, but that makes that line a particular kind of line. What kind of line is that line? What is that line AD? It's an altitude. It's a height of a triangle. What angle does it make with the bottom?
90 degrees.
90 degrees.
Angle bisector.
It's not even an angle bisector. It's just a 90-degree line. Okay? And so they gave us this angle, and they gave us this little angle up here, right? What kind of triangle is that where the markings are? If I were to ignore the other side.
30, 60, 90.
Not necessarily, but it is a particular type of triangle. Do you know what kind of triangle that is? Okay, so I'm going to redraw it by hand here. Oops. I'm just going to take that other side out. What kind of triangle did I just draw there?
A right triangle.
A right triangle. It's a right triangle. So these two angles are very, they have a relationship. Do you know what kind of relationship they have? If you know that that is the right angle in the right triangle, do you know what these two angles are called? It starts with a C. Complementary. Have you heard of the word complementary? You knew that? Okay. So what do complementary angles add up to? 90. So that's what you're going to do. You're going to take those two angles and just set them equal to 90. Tell me what the two formulas are.
7x minus 2. 2x plus 2. And then it wants angle BAD, but it already gave us BAD.
It gave you the formula for it, but did it give you the angle for it?
Plug x in there. Tenon, I mean.
Okay, good. I just wrote the numbers in the wrong spot, but I couldn't tell which one was which.
So we equal those two.
Yep, if it's a median, it's the midpoint, so yeah. And BD, yeah, it's 26. Good.
Well, I know these ones are, well, I think that's what they are.
Read the question to me, and then tell me what you think.
Oh, never mind, that's not what I thought they were. I thought they were proportions, because I missed one of those last time I came in. I'm going to find those.
Okay. There you go. What kind of line is y plus 5?
Median.
A median. Good.
Do I separate them first? Oh, I don't know what I mean. That doesn't make another check.
When you have a median line, the two parallel lines have a particular relationship with one another. Do you remember what they are? So I'm saying these two. Remember, this one is twice as big as that one, right? So if I know that this one is twice as big as that one, then what would this line be equal to? What would this line be equal to?
10.
10. So you can solve for y doing that.
So y is 5.
So y is 5, right.
And then we just...
They just eat them. Yeah, they're equal to one another. Well, you're divided by -1, not at negative x, right?
But...
I want you to do 48, because that's a proportion question. Multiply it through both of them. Hold on. Multiply the 8 through both. Now, just for giggles, I want you to prove that by using the other side. I want to show you this. I'm going to do it. Because I want you to see something, because I don't want you to do too much work. So that's one triangle. That's the other triangle. This one was 8, and this one was 12, and this was 2x, and this side was 2x plus 3. And you already said that 2x over 2x plus 3 is equal to 8 over 12, right? And you got x was equal to 3, right? So if I look at the numbers and I stick 3 into this bottom number,
9 plus 1.
what's 9 plus 1?
10.
And then I'm going to stick it into this one.
24 minus 9.
It equals 15. So now this is how I'm going to check. I'm going to start off with my scale factor. So my scale factor is just these two numbers. It's that first ratio, right? So I'm going to write 8 over 12. That scale factor has to be true for all of the lines. So I'm going to take this and I'm going to put these two numbers in a fraction together. So I get 10, because that's from the small triangle, right? Over 15, because that's from the big triangle. Now, in your calculator, all you have to do is cross multiply and see if you get the same number. So that's 120. And you know the other one is 120, right? So that's a way that you can quickly check to see if your answer is actually right. Does that make sense? Normally when I'm doing proportions, I always try to do it with the scale factor. So I'm going to figure out what my scale factor is when I go from one triangle to the other. And that's a check. I guess that's another one too, isn't it?
I can separate. I kind of confused.
Okay. I do want you to draw them separately. So your triangles are like, that's one, right? And that's the other one, right? This is x, and this is 4. And this is x plus 3, and this side is 6. Okay, so I have this angle and that angle, and they're equal to one another, right? So remember, the relationship is if the angles are equal, then the sides are proportional to one another. So that one and that one. That's how you can actually look at it. Okay, so since they're proportional, this is what I'm going to do. I'm going to say that x is equal to 4. That's how I'm going to start off my ratios. Now I'm going to make a fraction line. I'm going to draw another marker. I'm actually going all the way through this so you can actually see it. I know that that line and that line are exactly the same line, right? Because they're the same line in the picture, right? So that means that these two sides have to be proportional to one another. What triangle is the 6 part of?
The bottom.
The bottom one. So it's got to go in this fraction. So I'm going to put 6 there. Then where does this x plus 3 go? There's only one more space for it, right? So it's got to go there. Do you see how I broke that down? Does that make sense? I always start off with the angle that's the same, and I put those two things equal to one another. That's how I start off my fraction, so I know I have the numbers in the right spot. Are you cool with that?
Mm-hmm.
Okay. All right, now just solve it.
it.
You forgot to multiply it all the way through? Has your teacher ever done this for you? Because that's the second time you made that mistake. Like if I'm going to write this out, I'm going to write this as 6x, and then this is equal to 4 times x plus 3 in parentheses. And then I'm going to do this. And I have kids do
I
that,
have done that.
so I don't forget to multiply, because that's a common mistake that most people make. Mhm. So if x is equal to 6, then this side is 6, and that side is what?
6. Wait. 12.
What number is that? With my chicken scratch.
3.
So what would this side be?
3. And 6.
Okay, so the 6 goes in where the x
Oh,
is.
6.
Plus,
9.
there you go. There you go. Okay, now we're going to check. We're going to make sure that our scale factor is the same. Okay, so I'm going to say that this over that, so 4 over 6, because that's the same thing that I had before, and then that has to be equal to 6 over 9. You see where I'm sticking the numbers and why I'm sticking them there? Now we cross multiply to make sure we get the same number. Do we get the same number when we cross multiply? What's the number?
36.
36. You get 36 is equal to 36, so I know that I've done the answer right. I know my answer's right. That's the check. You set up the proportion, I'll tell you whether they're right or not. You see the fraction by looking at the triangle now? See how that's a fraction line? You did that perfectly. Now go ahead and do it.
I might have said
I think that that's right. It's 20 1/4. Okay, so let me do it this way just to double check. So you have 18 over x is equal to 24 over 27. What I would have done would be to reduce this by 3, because I don't like working with big numbers. So if I divide that one by 3, what do you get?
8.
If I divide that one by 3, what do you get?
9.
I'm going to show you something that has to do with fractions. You see how that number and that number are at the same level? That means that I can reduce those two numbers too. So what number goes into both 18 and 8?
2.
2. So that changes to a
4.
And this one changes to a
9.
9. And now I can cross multiply. So I have 81 is equal to 4x, right? And you get the same answer, right? So that's it. This is when you're going to have to use scale factor. So let me draw these two. All right, so I want to put an S in the one that's the small one, and I'm going to put a B in the one that's the big one. I know that they're already proportional to one another, right? So I'm going to put this 3 here, and the only number that I'm going to write on the big one is the number that's in that same exact spot. Which number is in the same exact spot as the 3? 5. I want to make sure that they're not trying to trick us. So the 3 is opposite the F. It's the third letter in the triangle, right? What's the third letter in this triangle? C. So that's opposite the 5. That's a way that you always can check. The reason that I want you to do that is because on the SOL, they will switch where these numbers are just to mess with you. So you always use the angle to figure out what sides are proportional to one another. You draw that line saying, okay, I have that angle, it's opposite that side. I have this angle, it's opposite that side. I want you to get in the habit of doing that because they'll trick you on your SOL. Okay, so if I want, and this is something you might not know about fractions, so I'm just going to say it out loud. If I wanted to scale down, then I need to have a fraction that's less than 1. So I'm going to put the small number on top and the big number on the bottom. That's the scale factor. If I want to scale up, then I need a number that's bigger than 1. So I'm going to put a 5 on the top, and I'm going to put a 3 on the bottom. Okay? Whatever I multiply by is either going to scale up or down. This is asking me for the perimeter, right? How do you find the perimeter of a shape?
Add all the sides.
Add all the sides. What's the only shape that I have the perimeter for in this picture?
Triangle.
ABC, right? So now I'm going to write the rest of the numbers in. I'll do them in a different color. So this is 7 and this is 6. So what is the perimeter for that? 18, good. So the perimeter is equal to 18. Now, if I'm going from this triangle to that triangle, do I scale up or down? Am I trying to make it bigger or smaller?
Down.
I'm scaling down. So I'm going to take this number and I'm going to multiply it by that scale factor because it's going to make the number smaller. So that means that 3 over 5 times 18 is equal to my second perimeter. So this is P1 and this is P2. So I need to find that second perimeter. And it's not going to go in evenly. You might as well just do it in your calculator. Give me something and a half, probably. Yeah.
10.8.
So this is 10.8. And so that's how you actually get the answer. And we notice that our perimeter, did that number get smaller or bigger?
Smaller.
Smaller, so I know I'm going in the right direction. When you do perimeter, it's exactly the same scale factor. When you do area, then you take your scale factor and you square it. So I would take 3 over 5 squared and then multiply. So if I knew this area and I wanted to scale down, I would take that scale factor squared and multiply it by that area. Do you remember doing that? Did you do area and volume?
Mm-hmm.
So you got to make sure that you find the scale factor and then you square it and then multiply in order to scale it up or down. And then volume, you take that exact same scale factor and you cube it. Because it's the sides cubed. So you have to cube it first and then multiply. All right. I don't know if you have any questions like that in this packet or not. It doesn't look like it. Looks like they just go over it. How are you at doing proofs?
I'm pretty good. Like, if I don't get it the first time, then I get it the second time. Like, I only miss one.
Awesome.
But when I see them, I'm like,
Nobody likes proofs. Not to begin with, anyway.
and I've got this before. I don't know if it's definition of midpoint or not. Or given.
It's given.
Oh, it says right there.
Yeah, it says right there.
Oops. I've never had to fill in one like this before.
Okay. What does that symbol mean?
The midpoint?
Mm-mm.
I don't know. I know what it stands for this, though.
That symbol right here means perpendicular. If the lines are perpendicular, then what can you say about the angles?
They're 90.
They're 90. So that's what they're trying to say here. Those are right angles. That's definition of perpendicular.
And like when I've done it on the computer, it always has like the thing, like choices. I've never had
to fill it in yourself.
But I can do this on probably. And I know what this is, but I don't know how to fill it in. PM is equals PM. I don't think that's right though.
Well, you got to fill that one in first, right? Don't put and. You actually have to write a mathematical statement. Right.
And then with this, I don't know if it would be P.
Reflexive means that you have the same line is equal to itself. So you have it right. PM is equal to PM. You have it right. Right. Now put in the markings of all the stuff that you've written so you can figure out what postulate you're going to use in order to prove that those two things are equal. Okay, let's go step at a time and let's write in this stuff. So, you said that these two are perpendicular to one another, so draw that in your picture. How do you symbolize the two things being perpendicular? Right. Right? And then you said that LM and MN are congruent to one another. How do you show that? Okay. And then you said that PM was congruent to itself. How do you show that? Okay. Now, what postulate can you use to prove that those two triangles are congruent to one another?
Side angle side.
Side angle side. Yes. So you just say side angle side down there. SAS, right? That's the shorthand for it. You don't have to write it all the way out. There you go. You could also use leg, but I don't know if your teacher taught you that or not.
So I still have a hard time with the similar thing, I think.
Mm-hmm. It would be side angle side because that angle and that angle are congruent to one another because they're what kind of angles? What kind of angles are they? Do you know the name of them?
Oh, they're vertical.
They're vertical. I want to make sure you put the letters in the right spot. Because if I do my proportion, let's see, I want to get 7 is equal to 3 and 14 is equal to 6.
How's it going?
Pretty good. So you did LP M, and then this is O N.
Oh, N. M. It should be M. not
M.
P. It's spelled out.
Okay, yeah. Whew.
Getting tested this morning.
No.
How many more questions do you have?
It's 67 questions.
Well, I know how to do those really good now.
Okay.
And I can do those.
We still haven't gotten to the trig stuff, but you should be able to do that.
Well, I'm really good at those actually. Like I love those.
We've been
because
practicing.
I love those because it's like algebra, and I had a 108.6 in algebra.
Awesome.
I love algebra.
Yeah, that once you start getting into that kind of thing, then I can hang. But
so that's pretty much all.
I love math,
but
not geometry.
But I get this stuff.
You get this stuff now.
Mm-hmm.
So I'm expecting an A, right?
If it's like this.
Please let me know how it goes.
Yeah, I will.
Even if I don't see you guys ever again,
Yeah.
just text me and let me know how it goes. And
Yeah.
if you need me again,
Sure.
you have my number and I
Yeah.
have yours now.
Yeah,
so.
we're gonna, see how it goes after the midterm with, the new stuff.
I don't like the new stuff.
There's some stuff we worked on, 'cause she's her lessons, every day, and what we worked on last night was really easy. I mean, you got that.
Yeah, but there was one thing.
Pretty part there.
But it was too late
There was
now.
a lesson before that. I was at work during the day, and she struggled with that. And
how much stuff do they cover each day?
Well, I had to do 3 lessons, which is like, I can show you.
It's a week's worth of
in
work
a day. So literally.
And it's taken her like all day.
So just the notes.
I'm sorry, I just
We didn't
laughed.
think it was gonna be this bad, when we signed up.
It's
for
pretty
it.
intensive when you try to do geometry
They
over the
kind
summer.
of told you they led you astray because they said at least 3 hours a day. So I'm like,
7
you can
hours.
easily handle 3 hours a day. That's not
Because it's
bad.
the only class you're taking, right?
And that but it's more like 8 or 9.
Really?
Okay, so this is just for one lesson. This first lesson is all this.
Yeah, I found a way to
And I had
print
to-
them so we don't have to rewrite them. Because that
All
takes
that.
time in and of
And I
itself.
had to take a test before this, and then I had to do 2 more of these. And
So there's 5 of those a week? There's literally like 5 of those a week?
No, this is just one, and then I have 2 more a day for this.
That was just one lesson. She had 3 of those.
And then I had.
In one day?
Yeah.
And then I had a test to do too.
Wow.
And
Okay.
I got a 100 on the test.
Yeah, we rocked the test.
That's because it was the cosine stuff. I like that.
Yeah.
When you get to the circle stuff, please give me a call because I can make it a lot more simple than they
teach it.
Because during that particular unit, I always get from my kids, why didn't they just say that? I get that a lot.
Yeah. Because we the lesson. She's on lesson like 8, and I think it goes to, what does it go to, 13?
But the midterm's not on that stuff.
Oh no, I know. Lesson 13
Oh,
through 13.4. So. every day there's usually like 10 has 5 different.
Right.
It just
Right.
depends. But I know
The
I was
shortest
working.
one was this one, but it had a quiz and a test.
I was trying to help her get ahead last night.
Mm-hmm.
So I was trying to
I'm not ahead.
just go in. Well, I was trying to because this is Monday's assignment. So if you can get through Monday this weekend, you're ahead.
Right.
But I was trying to do like